2, lesson 3. We're going to talk about rational exponents. What that is just a fancy way of saying when your exponent is a fraction, right? So rational exponent means your exponent is a fraction. So this opening exercise, actually, we're not going to do. We're going to skip right on through. And then we're also not going to do this. We're going to start right here. All right? So what is the fourth root of 16? In other words, what is, whoa. What is that? So you're being asked, what number times itself 4 times is 16? So 4 times 4 times 4 is bigger than 16, right? 2, right? So it'll be 2. And why? Because 2 to the 4th power is 16, right? Just going backwards. So then what they're asking here when they say the cube root of 125, they're asking you to find what that is. So a number times itself 3 times is 125, whatever that number is. 5, right? Yeah. Because 5 to the 3rd power is 125, right? So we're just going backwards. So, how about this one? We're being asked for the 5th root of 100,000. What do you think that is? 10. All right, moving right along. How about this? The 4th root of 81. So how about this? If you're not sure, if it's weird, if it's one that you're not super familiar with, I'm going to show you something, okay? So, number 1, I'm going to point out this property. So this is what this thing is all about. We have a property that tells us that if we have some nth root of a to the m power, that is the same thing as a to the m over n power. Okay? So the number on the outside is going to go in your denominator. The number on the inside goes in your numerator. And something that goes along with that would be the case that if you have some nth root of a, it's just going to be a to the 1 over n, right? Because it's like there's a 1 there, right? You know what I'm saying? Yeah. Okay. Hey, another rule that we're going to have is that if you have some nth root of a over b, that's the same thing as the nth root of a over the nth root of b. Okay? And that's pretty much what we're going to be using, those 3 properties throughout this lesson. Yeah. So, we could rewrite this. So if you didn't know what this is, you could rewrite it like this. It's 81 to the 1/4 power. And you can go to your handy-dandy calculator. And if you have an operating system that allows you to do it, the easiest thing would be to go to selection number 5. And you would put 4 and 81 there. And get the answer is 3. So you can use your calculator function. It's good if you don't have to, but if you do, that's okay. I wanted to show you that these two things were the same. 81 to the 1/4 power. Now, if you have a TI-83, so if you have one of these guys, you have to enter it like this. You have to actually put the 1/4 in parentheses, or it doesn't understand that you want to do 81 to the 1/4 because 81 to the first power divided by 4. It screws it up. Okay? And you get 3, which is the same thing. Okay. So then what's this? You can put it in your calculator, or you could say, hey, what times is 5 times is 32? It's going to be 2, right? With this one, we have a property of radicals that we've learned about that says that if I have the nth root of A times the nth root of B, that's going to be the same thing as the nth root of A times B. And so then we can write this as the cube root of 9 times 3, which is going to be the cube root of 27, which is 3, because 3 times 3 times 3 is 27. Okay, for this one, we're going to do the same thing. We could write these as the 4th root of 25 times 100 times 4, which is the same thing as 100 times 100, right? Since 4 times 25 is 100. 100 times 100 is 10,000. And the cube root of 10, or the 4th root of 10,000 is just 10. So, don't know why this is a big discussion. We're going to use our property that says, remember that if I have the nth root of a to the m, that's the same thing as a to the m over n. So in this case, that right there is m. Our denominator here is n, and that's a, right? And we can just plug them all into this thing. So that becomes, okay, n is 4, so we put the 4 there. And a is 2, and m is 3, okay? Just remember, the denominator goes on the outside, the numerator goes on the inside. So, that is the same thing as the 4th root of 8. And I don't think we can simplify that, right? Because there's no number that you can multiply itself 4 times and get 8. So we'll just leave it like that. Okay. This one, let's rewrite it. So, remember, this denominator goes on the outside. That's going to go on the inside, the 3, and it's to the first power, so we don't really need to write the power here, right? How about this one? Remember, the denominator goes on the outside. what goes, and then our base goes on the inside. Okay. Oh. All right. So for this one, we're going to write this as so the 5 goes there, right? So that's the 5th root of 1/4. And we're going to leave it at that. Technically, we should rationalize our denominator, but we're not going to do that. All right. And this one, the 10th root of 6. And I think you're seeing the pattern, right? And now we'll get to answering your question. What happens when there's not a 1 in your numerator, right? Well, remember the denominator goes on the outside, the base goes in there, and then our numerator will go right there. So this becomes the square root of 8. Can we simplify that? No, 8 has no square root, right? So moving right along. Again, this denominator on the outside, my base will go on the inside, and then this numerator will be the exponent. So that is the square root of 4 to the 5th power, 1024. Does 1024 have a square root? We can go to our handy-dandy calculator and go square root of 1024. And indeed, 32 times 32 is 1024. So just check it. If you get a whole number answer, you'll put your whole number answer. If you got a decimal, you would just leave it. So for instance, if we put this in our calculator, if we put the one above it, right, which was the square root of 8, we get a decimal, right? So we'll just leave it as the square root of 8. But for the second one, we got a whole number, so we're going to actually write that whole number down. Okie dokie. So this is going to be the cube root of 1/8 to the 5th power. Oh, brother, I have a feeling we can simplify this a lot. Oh, brother. Okay. So, this becomes the cube root of 1 to the 5th over 8 to the 5th, right? Because we raised everything in our parentheses to that power. So this is going to become the cube root of 1 over, what is 8 to the 5th power? Alright. Is there a cube root of it? Because remember, we can write this as the cube root of 1 over the cube root of 32,768. What was it? 32. Cube root of 1 is 1. And that's 32. So you'll do a little bit of calculator work with this as well. Okay. Let's show why this statement is true. Well, clearly it's true because a to the negative m is equal to 1 over a to the m, right? But let's do some algebra. Check it out. What if I multiply both sides by 2 to the 1/2 power? Those are going to cancel out because that's 1, right? And I'll have 2 to the 1/2 power times 2 to the negative 1/2 power is equal to 1. If we wanted to combine these two things, what would we do to our exponents? Yeah, you would add them. So if we add that, 1/2 minus 1/2 is 0. And that's true, right? So we just verified that that was true using some algebra. Super. So now we have some negative exponents to deal with, and I do believe these are our last 3. So here we go. So if we use that property, this is 1 over positive 4 to the positive 3/2, right? Instead of 4 to the negative 3/2. And then we can write this as 1 over the square root of 4 to the 3rd. Remember? You're just following that pattern. Just following a pattern. So this becomes 1 over the square root of 4 to the 3rd. 4 times 4 times 4 is 64. 64 has a square root, huh? It is 8. And then we're done with that particular problem. Nextly, I like making up words. Alright. We're going to write this with a positive exponent by putting it into our denominator, making the exponent positive. And then we'll rewrite this as a radical. So the denominator outside, the base there, and we'll raise it to the numerator. And that becomes what is 27 squared? 729. Does 729 have a cube root? So that becomes 190. Okay, last one. This becomes 1 over 1/4 to the positive 1/2 power, right? Which is 1 over, I'm going to raise everything in my parentheses to the 1/2, so this is 1 to the 1/2 over 4 to the 1/2, right? Both my numerator and my denominator get raised to the power outside my parentheses. 1 to the 1/2 power is, well, I'm going to rewrite this as the square root of 1 over the square root of 4. Just messing with my denominator right now, okay? All I'm doing is using properties on my denominator. So that's 1 over, the square root of 1 is 1. The square root of 4 is 2. When I flip and multiply, I get just 2. And I'm going to show you why. This says, right, 1 divided by 1/2, right? That's what that says, which is the same thing as 1 over 1. Remember, I flip and multiply. 1 is the same thing as 1 over 1. Change my division to multiplication, and I flip what comes after it, which is 2. So that's how I get there. Well, all right. That's it. Lesson 3 is done.